So in the last video, I looked at testing whether two things are related. And if we decide they are related, whether we're using a formal test or whether we're using those strong relation cutoff lines that are in Chapter 4, Section 4.1, we can decide, okay, if they are correlated, how do we use this regression equation? What does the slope and intercept tell us? How can we use it? So the next couple examples are looking at taking this and then making predictions. So if they are correlated, we can plug our numbers into that formula that we got, the y equals a plus bx, and come out with a result for y. If they're not correlated, our best estimate is actually the mean. So in this first example, we've got some data. We can calculate that slope, the intercept, and the correlation coefficient just with using Excel or our calculators. Certainly if we have a fairly large data set, I would recommend using Excel. It's kind of tedious to plug into the calculator. And if it's a small data set, probably either way works. So again, we plug that in, compare our test statistic to our t-table value. So here we get a test statistic of 5.470. We get a critical value from our table of plus or minus 1.703. So we're definitely in the critical region. So there is significant linear correlation. So we have a trend. So we can take that slope and intercept and put them into our equation. And I see I used the notation from the other textbook, so let me fix that.
Before Jazz comes.
So when we've got that, we plug that in, and it's saying predict if for month 35. Right, so we're not that far up. So we're going to be assuming that this trend continues. We predict for month 35, and we get this. I will point out with these predictions that interpolation, so in predicting values in between values you already have, is always going to be more reliable than extrapolation, which is predicting values outside of those values. So this one is extrapolation. It's making a fairly big assumption that this trend is going to continue. So if the trend does not continue, this prediction could be fairly far off. So next one, again, this one's a little shorter. You might want to use a calculator to this. So this one would be an example of interpolation. Our x value that we're predicting for is in between two values. And so our calculator output for this one, we get a much lower r. And we see when we plug that in, we get a test statistic that is very small, does not fall in our critical region, so there's not significant linear correlation. So when we come to that conclusion, we would not use our slope and our intercept to make that prediction.
Darlene.
And in fact, what we would use for prediction is our means if we wanted to make a prediction with this one. So if we were going to predict y, it wouldn't matter what our x is, we would just predict using the average y value. If we wanted to predict x, it wouldn't matter what y we're looking at, we would just predict our average value from the x's. So when we do have correlation, we can use the equation to make predictions. When we don't have correlation, we can't use the equation. And again, we can use Excel to help us on these ones, to find the mean as well as finding r. And so we'll stop that one there.